Hey guys, welcome back to another lecture video for Chem 104. In this lecture video, we are going to learn how to draw alkenes with an ENE at the very end. If we are given the IUPAC name, we're also going to learn how to draw alkynes if the IUPAC name of the organic compound is given. And last but not least, we're going to talk about how to name alkynes. Hopefully after the end of this lecture video, you guys can look upon this initial screen and hopefully understand the chemistry joke. All right, so let's go ahead and get started. The first thing that we're going to do is we're going to get some practice on how to draw alkenes given its IUPAC nomenclature. And so here, this is already a specific name of an organic compound. All we have to do is break it down into parts so that we can draw it out using the skeletal structure. And so whenever you guys are drawing any compounds from its IUPAC name, you always want to look towards the end, because if you guys recall, the end represents the parent, the name of the parent chain. And so here I see hept, and that's going to prompt me to think about 7 carbons, and this ENE tells me that there's a double bond somewhere. And for me to understand where the location is of that double bond, I'm going to have to look at the number before the hept, before the prefix that describes the number of carbons in my parent chain. And so it looks like I have a double bond on the first carbon of my parent chain. And so now that I've kind of deciphered what's going on in this section right here, I'm going to go ahead and draw that out, because that's going to give me like the foundation of how I'm going to place everything else. And so if you guys recall, everything else to the left of that squiggly line that I just drew is going to represent all of your substituents. And you cannot draw your substituents if you guys do not have your parent chain drawn. Okay. All right, so heptene is what we're trying to draw, 1 heptene specifically. And so we have to have 7 carbons. So the moment you put your pen or pencil down, that is carbon 1, and the other end is carbon 2. So right now I have 2 carbons on this skeletal structure. And then this is going to be 3, 4, 5, 6, 7. Okay. So I've finished describing the 7 carbons. Now I want to draw in my double bond. And my double bond is going to be on the first carbon on my parent chain. And so I'm going to go ahead and draw a double bond like this. Okay. Now, if you guys wanted to draw the double bond on the other side, you guys can. And so for me, I've always just drawn my double bonds kind of like tucked underneath the structure. All right, so now that I've drawn my double bonds, I'm going to go from left to right and start placing my substituents on my organic compound. And so here I have 2,3-dibromo. So this is telling me that I have to place it on the second and the third. Now, if I refer to this carbon on the left as carbon number 1 arbitrarily, and actually you guys can do this backwards too, so I apologize for me not mentioning that. So if you guys wanted to identify that the carbon on the right is carbon number 1, you guys can go ahead and do so. But you just have to make sure that you can't say this is 2. This has to be 2 if you guys are going from the right to the left. So just be consistent in the numbering of your carbons. And so if I am arbitrarily assigning this carbon on the left as carbon number 1, then this is carbon number 2, 3, 4, 5, 6, and 7. Okay. So now that I've labeled my positions, or I've labeled the carbon numbers on my parent chain, I'm going to go ahead and start attaching substituents on these carbons. So here I have, so here we have dibromo. So we have 2 bromines that we need to place. And so the first bromine is going to go on the second carbon on the parent chain. So I'm going to draw a bond that'll link that to bromine. And then the second bromine is going to go on the third carbon, and I'm going to draw a bond linking the parent chain to bromine. Okay, so that's my 2,3-dibromo. Okay, so I've checked that off. Next, on the 4th position, I have an ethyl. And so I'm going to go ahead and erase this 4 because it's kind of in the way. And I'm going to draw a bond that links it to the first carbon of ethyl. And then so since eth means 2 carbons, I need to draw another carbon. And I'm representing those 2 carbons as the corners or the endpoints of a line. Okay. And so that's done. The last thing is 4-methyl. And so on the same carbon, now you guys can either put it here or here or whatever. It just has to be attached to the 4th carbon. So I'm going to go ahead and just place it down here so that the compound is not very cluttered. Now, if you want, like I said earlier, you guys can go ahead and place that methyl group here as well, and that is okay, just as long as it's on carbon 4. Okay, so this is carbon 4. All right, and so we finished placing the substituent once we have the foundation down. And so I'm going to go ahead and erase all of these numbers just so it looks clean. I don't need them anymore because I've placed everything. And so this is the organic structure for this specific alkene. All right, and so really your first key step is to be able to draw your parent chain and then number your carbons so you know where to place your substituents. Let's go ahead and look at another example. So this is 3,3-3,3-dipropyl-1, 4-octadiene, right? And so diene means 2 double bonds. So with that said, hopefully you guys got the organic chemistry joke at the very beginning of this lecture video. All right, so very similar to what we did at the very beginning, we're going to look at the very end, just like decompose this. So octa is referring to 8 carbons. And then here we have a di and then ene. And so that means we have 2 double bonds. Okay. And the position of those 2 double bonds is going to be on carbon 1 and carbon 4. Okay. And so everything to the left of that number is going to be my substituent. And so I'm going to ignore that for now. And I want to just focus on the right side of that squiggly line that I marked, because that's going to be my parent chain. So octadiene. So the moment you put your pencil down, that's carbon 1, 2, 3, 4, 5, 6, 6, 7, 8, and I'm done. Okay. And so I'm going to start labeling my carbon number 1, 2, 3, 4, 5, 6, 7, and 8. And once again, you guys can go ahead and go from right to left or left to right. You're building your own organic compound. And so you can arbitrarily place that number. You can start it from the left or the right. Okay, just make sure you follow through. All right, so here we have octa, so we finished the 8 carbons. Now we need to figure out the diene part. And so it's on 1 and 4. And so whenever you're drawing a diene, this one means this is where the double bond starts. So the double bond starts at carbon 1. There's also a double bond that starts at carbon 4. Okay. Right? So hopefully you guys got that. So I'm making that line, that double bond, starting from 4 and ending at 5, starting at 1, ending at 2. All right, so now that I have the position of the 2 double bonds, I'm done with that. So that kind of checks that off. And the last thing I need to do is add my propyl groups. And so notice that you see the word di. That means you have 2 propyl groups. And prop means 3. So you have 2 3-carbon chain substituents. So let's look and see how that works. So on the 3rd carbon, we have a propyl. So 1, that's 1 right here, 2, and 3. Okay. And so I'm going to go ahead and just erase the little circles there, just so I get nice, clean lines. And so those little dots that I've been placing just is to communicate to you that a carbon is present. And remember, those carbons are filled with invisible hydrogens, such that it follows the octet rule. Now, I've only put 1 propyl group, and the name tells me that I have 2, and they're both on the same carbon number, which is carbon 3 on the parent chain. And so I'm going to go ahead and put another one, so that's carbon 1, carbon 2, and carbon 3. So this is going to be my organic structure based on the name that's given to me. Okay. Now, if you guys wanted to place your propyl groups on the same side, you definitely can. Just make sure that they're not clashing. So I can have 1, 2, and 3. Something like that. Okay. So either way, it'll give you guys the same answer because you have 1, 2, 3 points on that line that represents the 3 carbons. All right, so hopefully you guys are picking up the pattern and drawing these alkenes. And let's go ahead and do one more before we talk about how to name alkynes. And so to name, to draw a triene, we're going to have to figure out the number of carbons in our parent chain. And so here I see nana. So nana is telling me I have 9 carbons. So let's go ahead and build that first. So we have 1. So this is 1, 2. This is 3 right here. 4, 5, 6, 7, 8, 9. Okay. Now, just to kind of vary it up, I'm going to go ahead and number it from right to left, just to showcase that you guys can either go from left to right or right to left when you're drawing your own organic compound from the IUPAC nomenclature that's given to you. Okay. And it's very wise for you guys to label your carbons just to double check that you actually place the correct number of carbons. That's typically the common mistake for new students taking or doing some type of organic chemistry. So now that we have the 9 carbons placed, we're going to read further, and it says that we have tri. So tri means 3. And we have 3 of what? Well, an ene represents a double bond, so we have 3 double bonds that we have to place on our parent structure, our parent chain. Now, the position of these double bonds can be found in the numbers directly before the nona. So position of the double bonds. Okay. So this is telling me that I will have a double bond starting from carbon 1. Okay. Now remember, a double bond only goes between 2 carbons. So if I'm starting from number 1, then I'm ending at carbon 2. Now the next one is 3, and so I'm starting from 3 and going to 4. Okay, I'm not going to go from 3 to 2, right? That doesn't make sense. You always go forward in terms of number. So 3 to 4. Now the next one is going to be on position 5. So we're going to start at 5. And then we're going to end in 6. And so here I have 3 consecutive triple bonds, and I have a triene, not a diene or a regular ene. Okay. So I have 3 triple bonds, 3 double bonds. And so now that I've indicated the positions of the double bonds, I'm going to go ahead and place my substituents on this parent structure. And so the first item I'm going to place is my 2-bromo. And so I am going to place a bromine on the second carbon. Now if you guys notice, I have 1, 2, let me see if I can do this in green, 3, 4, right? I have 4 bonds on carbon 2, which fulfills the octet rule. Okay. So you don't want to break your octet rule. You always want 4 bonds on each carbon. It can either be all single bonds or a combination of single, double, or triple bonds. All right, so and so we've gone ahead and finished this. And let's go ahead and do 3,4-dichloro. So this is telling me that I have 2 chlorines that I need to place. And the position of those 2 chlorines is on carbon 3 and carbon 4. And so on carbon 3, I'm going to go ahead and place a chlorine. Okay. So if you look, I have 1, 2, 3, 4 bonds on the 3rd carbon. So I didn't really break my octet rule. I'm just at the octet. And same thing for 4. Okay. Now if I go ahead and erase these numbers, okay, this is going to be the organic compound that is described by the name that's given. Okay. All right, so hopefully by going through these 3 examples, let me go ahead and erase these numbers here just so they're a little bit clean. Okay. So if you guys are looking through what we did, hopefully you guys understand how to break down the name and be able to draw the skeletal structure from it. All right, so the next topic that we're going to cover is naming alkynes. So we're moving from double bonds to triple bonds. And so the first step, like in all steps when we're trying to name any alkyl groups or organic compounds, is that we're going to find the longest chain containing, this time, a triple bond. And when we name this triple bond, we are going to use the YNE suffix. And so we're not going to use the ENE. The ENE is reserved for double bonds. And after we figure out the longest chain, we're going to go ahead and number the carbon chain to give the triple bond the lowest carbon number. And so once again, we kind of see a shift in prioritization between our halogen and alkyl substituents to that of the triple bond. And so, when you guys are dealing with double bonds and triple bonds, you guys don't need to add the carbon number on the parent chain to see which one is the lowest. You're always going to focus on the triple bond or the double bond and make sure those two items get the lowest carbon number on your parent chain. Okay. All right, so after you guys have determined your numbering system such that the triple bond or double bond gets the lowest carbon number, then you guys are going to identify the substituents and you guys are going to name them by parts, just like what I've done in several lecture videos. And then after you name all the different parts, you're going to name the entire molecule together. And you want to make sure that your substituents are always in alphabetical order if there are more than one different types. Substituents needs to be in alphabetical order. Okay. All right, so let's go ahead and start. So looking at this structure, this organic compound, it's a skeletal structure. I need to identify how many carbons I have in my parent structure. And so when you guys are working with, and once again, I'm going to use pink, the highlighter pink, to identify the carbons that's present in the parent chain. And when you guys are trying to identify the carbons using the triple bond or with the triple bond present, the left side and the right side of the triple bond represents one carbon. So what does that mean? So I have 1, 2, 3, 4. Okay, and so I'll go ahead and mark. So this point right here, notice that the end points of both the left and the right side of the triple bond will represent one carbon, right? And so this is, if you guys are trying to imagine what this looks like, it's kind of like carbon, triple bond, carbon, and then there's that carbon, which is this carbon here. And then, so this carbon is that carbon is this, and then there's this another single bond, and then there's that carbon right here, okay? And this carbon, the last carbon that I just wrote, is connected to another carbon up here, and then it's connected to chlorine, and then it's connected to another carbon. Okay, and so hopefully by translating this skeletal structure, just to see the carbons, you guys understand how you guys understand why I highlighted the two carbons in pink on either ends of the triple bond. Okay. So I'll just go ahead and erase some of this stuff. Okay. And so in the fourth carbon, I have two paths. I can go up or I can go down. Doesn't really matter because they'll both give me the same carbon number, which in this case is 5. So since I have 5 carbons in my parent chain, I'm going to use pent. Okay. Maybe I'll erase this, give it some more space. Okay. So 5 carbons is pent. And I have a triple bond, so I need to use the suffix yne, pentyne, okay, all in one word. And so the next item that we need to accomplish, so I labeled my yne and I figured out my longest chain containing the triple bond. Next, I'm going to number my carbon chain, and I'm going to number it so that the triple bond gets the lowest carbon number. And so I'll go ahead and use blue to go from left to right. So 1, 2, 3, 4, and 5. And if I go from left to right, I'm focused on my triple bond, right? So the beginning of my triple bond, if I go from left to right, starts at carbon 2. Okay, so carbon 2 is the carbon number that will start my triple bond. Okay, and so I'm going to go ahead and go from right to left in green. And so I'm going to start from this point 1, 2, 3, 4, 5. And so if you guys look, if I go from right to left, the triple bond will start at carbon 3. And so you really don't want this. It's a higher value. So this is letting us know that the numbering system in green is incorrect and the numbering system in blue is much preferred. Okay. And so now I'm going to go ahead and just describe, I still need to describe the position of where that triple bond starts, which is on carbon 2. So I'm going to say 2 pentyne, okay, where this 2 represents where the triple bond is located. Okay. All right, so anything that I didn't highlight in pink, it's going to be a substituent. So I have 2 substituents in this case. Here, oops, maybe I should just bring this down. So here I have on the 4th carbon, right? So notice that there's a connection to the 4th carbon. I have a methyl group, so I'm going to put in 4-methyl. And if I look on the chlorine, notice the connection is on the 4th carbon as well. And so I'm going to go ahead and describe this substituent as 4-chloro. Now, now that I've named all the pieces, I need to put them together correctly. And so here I see that chloro has a C, methyl starts with an M, and those are our 2 substituents. And so we're probably going to have to name this one first because C is closer to the beginning of the alphabet. And then we're going to go ahead and name this second. Okay. And now that I have all of my substituents numbered and how I'm going to name it in my final answer, I'm going to go ahead and name the parent chain last. So it's 1, 2, and 3. We're going to go ahead and name it in that order. So here I have 4-chloro. Then I'm going to put 4-methyl. Next, I'm going to put 2-pentyne. And we want to make sure that our grammar in our nomenclature is correct. And so I'm going from letter to number. I need to put a dash. Letter to number, I need to put a dash. If it's number to number, it's a comma. If it's letter to letter, then there's no dash, no comma, no space. It's all just clumped into one. Okay, so this is the name for this organic compound. 4-chloro, 4-methyl, 2-pentyne. All right, so let's go ahead and look at another example. Just to reinforce what we've kind of done for pentynes, or I'm sorry, not for pentynes, for alkynes. The first step is to identify the longest chain containing the triple bond. So this is 1, 2, 3, 4, 5. Now I have a whole bunch of branch points, but it looks like if I choose this or this, it'll still give me the same carbon number. So I'll just stick with this for now. Okay. And so if you count the number of pink dots that you see that describes the longest consecutive carbon chain, I have 6. And so if I have 6 carbons, then that's going to represent hex. And so since I have a triple bond present, then I need to put in the YNE ending, hex-ine. Okay. Now I'm not going to put in hexa-ine, so please don't put hexa-ine. So this, actually this spelling is wrong. Don't put in an A. That A is typically found for if it's like 2 double bonds, like hexadiene or something like that, or pentatriene or something like that. Okay. But if it's just if there's just only one double or triple bond, you don't need to put in the A in between the 2 consonants. Okay. All right, so we have to number. We have to figure out our number system so we can describe where that triple bond is located on our organic compound. And if you look from left to right, it's already here. It's already in carbon 1. So there's no point for us to go from right to left. So this is carbon 1, 2, 3, 4, 5, and 6. Okay. So on carbon 1, we have a triple bond. All right, so now that we have the triple bond, we're going to go ahead and identify our substituents. So I have one there, and one here. Okay. And so if you look at the identity of the substituents, it's just one line ending in 1 point. So that means it's a methyl group. So I have a 3-methyl. I have a 5-methyl. I have a 4-methyl. And so if you guys look at the name, methyl, 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 they're all the same. So I'm going to clump them up and order it from increasing number of, so 3, 4, then 5, right? So I'm going to put in 3, comma, 4, comma, 5, because I'm putting all of the same substituents together. And then I need to put a dash. And since I have 3 methyl groups, I need to put in trimethyl. Okay, so 3, 4, 5, trimethyl. and that will sum up all of the substituents. Okay, notice that they're all the same, so I didn't like number which one I'm going to put first, second, or third. I'm just going to clump them all into one. And then the last thing that I need to describe is the parent chain, so it's one hex sign. And to make sure that my nomenclature grammar is correct, letter to number, right? So that's in number 1. And so I need a dash. Okay. And so that is going to be the name of this organic compound. Okay. All right, so we're going to go ahead and do one more, I believe. Yeah. So we'll go ahead and go over one more organic compound, and then we'll go from the IUPAC nomenclature to the actual structure. So we're going to draw it out. All right, so let's go ahead and start from the very beginning. We need to identify the longest carbon chain. And I'm going to start from left to right. I'm going to go from left to right. 1, 2, 3, 4. Right. So remember, either ends of the carbon or either ends of that triple bond represents 2 carbons. So 1, 2, 3, 4, and this is 5, and then this is 6, 7. Okay. Once again, I'll draw it in. 6, 7, 8, 9, and 10. Or 10. Okay, it doesn't matter. And so since I have 10 carbons, I'm going to use the prefix dec. And since I have triple bonds, I need to put in -ine. But if you look, I have 1, 2 triple bonds, so I need to put in deca. Okay, now because remember now this is plural, we have more than one triple bond, so I need to put a vowel between the 2 consonants. Deca, die, ein. Okay. So deca, die, meaning 2, ein, meaning triple bonds. Okay, so hopefully you guys understood that. All right, so we need to describe where those triple bonds are located on the parent chain. And so we need to figure out the numbering system. So it looks like my triple bonds are kind of like right in the middle. So I just want to make sure that I'm numbering it correctly. I'm going to go ahead and use light blue to go from left to right. So if I'm going from left to right, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And so if I'm going from left to right, notice that when I hit 3, my triple bond starts. So my triple bond starts at 3. And if I keep on moving over, notice that carbon 6, I hit another triple bond. Okay. So 3 and 6 are the carbons that I see the triple bonds start forming. All right, let me erase some of this stuff. Getting cluttered. So I'm going to go in reverse, just to make sure that my numbering system is correct. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. Now, if I go from right to left, okay, I notice that when I hit carbon 4, my triple bond starts. So right to left, my triple bond starts at 4, ends at 5. I'm going to continue. And when I hit 7, I get another carbon with a triple bond. And so if you look at this, these two have a lower value if I go from left to right. So therefore, I'm going to keep that numbering system and erase the other numbering system. Okay. So now that I have my numbering system intact, at carbon 3 and at carbon 6, it looks like I have my triple bond. So I'm going to put in 3, 6, and this 3, 6 is going to represent the di-ine. Okay. And the dec, or the deca in this case, is going to represent the 10 carbons. So the last thing I need to do is describe my substituents and where they're located on the parent chain. So I have 1, 2, and 3. Okay. So it looks like here I have a 2 iodo, and I have an 8 iodo. Last but not least, I have a 9 methyl. Okay. All right. And so notice I have different substituents. I have an iodo and I have a methyl. And so what that means is that I need to organize my substituents in alphabetical order. So I comes first before M. And so therefore I'm going to combine both of these together, right? But this is the first item I'm going to describe. And then the second item I'm going to describe is the methyl. And the third item I'm going to describe is my parent chain. Okay. So let's go ahead and put this in alphabetical order and come up with my final answer. So I have 2, 8 dash di iodo, and there are 2 consecutive i's. Just think about it in terms of like syllables, how you pronounce it. If you don't have the second I, you're going to pronounce it like diodo or something like that, or diodo. So it's be di iodo. Okay. All right. So the next one is 9 methyl, and the last one is going to be 3, 6 deca di-ine. Okay. And so the first 2 are my substituents. My 2,8 diodo is my first substituent that I marked in red, is number 1, and 9 methyl is number 2, and 3, 6 decadiene, that's number 3. So to make sure that I've built this up correctly, final answer, I need to think about whether or not I'm going to put commas, dashes, or no spaces. And so letter to number, dash, letter to number, dash. And I'm done. So this is my final answer. All right, so hopefully after going through 3 examples of naming hex signs, I'm sorry, not hex signs, alkynes, we are good to go. Okay, so just make sure you guys are going through the PowerPoints, going through the worksheets, and reinforcing this material. So the last part to this lecture video is going in reverse. How do I go from an IUPAC name to the skeletal structure? Okay. So very similar to the alkenes and alkanes, you want to look at the last part. Okay. So here we have a decine. Remember, so if you look, there's no A, it's decine. You only have that, you only put deca if the ine is plural, if you have more than two, or if you have two or more triple bonds. Okay, so like decadiene, decatriene, decatetraene. But if it's just one triple bond or one double bond, there's no A. Okay. All right, so for 5-decene, we're going to go ahead and decompose this. So dec means 10 carbons. And so let's go ahead and draw that. So 1, 2, 3, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. So here we have 10 carbons, and we are going to describe the position of the triple bond, the ine, by looking at the number in front of dec. Okay, so it's on carbon 5. And so I'm going to label this as 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So on the 5th carbon, which is right here, I'm going to have a triple bond. Okay. Now, this is just a rough draft, so we're going to have to redraw this, because remember, this is a triple bond and needs 180 degrees. Okay. All right, so now that I've drawn my parent chain, I'm going to go ahead and figure out where my substituents are going to be attached to my parent chain. And so on the 3rd carbon, I have an isopropyl group. So this is carbon 3. Isopropyl. Propyl means 3, and iso means there's symmetry. Oops. All right, and so that's going to be my 3-isopropyl. Next thing is my 7-methyl. And I'm going to go ahead and erase that 7 and replace it with a methyl group. Okay. And so now that I have all of my substituents, I need to redraw this to make sure that this is 180 degrees. Okay. So I'm going to go ahead and take, so it's going to be 1, 2, that stays the same, 3 stays the same, 4 stays the same, 5. Okay, so this is carbon 5, and carbon 5 needs to be 180 degrees, and so I need to draw a line. And so this point is now carbon 6. Okay. And so then carbon 6 needs to go further out, and this is going to be carbon 7. Then from carbon 7, you can go up. Okay. So let me put carbon 7 over here, carbon 3 over here. And then now I'm on 8. And then I can go down 9, up 10. Okay. And so now I need to make sure my substituents are on this thing correctly. And so 1, 2, 3. So this is 1, 2, 3. I have my isopropyl. You guys can draw your isopropyl going up or down, doesn't matter. Just make sure it's an isopropyl. Okay. So nothing on 4. 5 and 6 are now 180 degrees. Okay. And 7 contains my methyl group. So I need to put, I'm going to erase this real quick. Put a methyl group on 7. And then 8, 9, 10, there's nothing on there. And so to clean up my work, I'm going to simply erase my numbers. So please don't forget about the 180-degree angle for triple bonds. Remember, it's linear in terms of electron geometry, and this is what our structure will look like. Okay. All right. So let's go ahead and look at another example. So very similar to the first, we're going to decompose this. So we have hex. Hex is 6 carbons. And we have an yne, and it's on the 3rd position. So here we have 1, 2, 1, 2, oops, 3, 4, 5, and 6. Okay. 1, 2, 3, 4, 5, and 6. And it looks like we have a triple bond on starting from the 3rd carbon. So here's carbon 3. Starting from the 3rd carbon, I have a triple bond. Okay. And so once again, we're probably going to have to redraw this. I need to make sure that this is 180. And so let's just go ahead and put on the rest. So I'm done with all my parent, and now I need to figure out my substituent. So I have 2 methyl groups, so it's a dimethyl. So dimethyl on 2 and 5. So on carbon 2, I have a methyl group. Carbon 5, I have another methyl group. Okay. All right, so we're going to go ahead and translate this such that the resulting compound has the correct geometry. So here I have 1, 2. Okay, so 1, 2 doesn't really change. This is 3, so 1, 2, 3. So notice 3 is where the triple bond starts. And so that means from 3 to 4, I cannot bend it. I have to represent it as a line or a triple bond. And so this is going to be carbon 4. Okay. And so carbon 4 to carbon 5, this also needs to be 180, right? So the bonds need to be 180. So that means from 4 to 5, this is also going to be a straight line. Okay. So once you're on the 5th carbon, then you guys can go up to carbon 6. Okay. All right, so now that we have the correct geometry in place for my triple bond, I'm going to go ahead and add my substituents. So I have a methyl group on carbon 2. And then I have a methyl group on carbon 5. And if I erase all of these extra stuff that I've placed, okay, this is going to be the organic structure, the skeletal structure for this organic compound. Okay. And so once again, triple bonds are a little bit finicky, not finicky, it's a little special. You need to make sure that either side of the carbon, those bonds are 180 degrees. Okay. All right, so we'll do one more, and then we're going to go ahead and move on to the next topic in another lecture video. Okay, so this one, there's a lot of things going on here, but let's look at the very end, and we have pent. So pent is a 5-carbon compound, and we have a triple bond, and the position of the triple bond is on the first carbon. So let's go ahead and start. So pent, so that's 5. 1, 2, 3, 4, and 5. Okay. And so now that I have all 5 carbons, I'm going to go ahead and place my substituents. Oh wait, before I do that, I need to put in my triple bond. And so my triple bond is on the first carbon. And so I'm going to put 1 and another 1. Oops. And so this is going to be carbon 1, 2, 3, 4, and 5. Once again, I need to make this structure 180, so I'll probably have to redo this. So for now, I have 3,4 difluoro. So I have a fluorine on carbon 3 and carbon 4. And I also have a 3,4 dimethyl. And so on the 4th carbon, I have a methyl group. On the 3rd carbon, I also have another methyl group. Okay. And so this is what it preliminarily looks like. And so let's go ahead and make sure that my triple bond is 180 degrees. And so starting from carbon 1, so this is carbon 1. Oops. And so if this is carbon 2, okay, so notice that I need to make this bend 180 degrees. Okay. So that means I need to push carbon 3 up. Okay. So that means I need to put carbon 3 up here. And then now I can bend it to represent carbon 4. And now I can go ahead and bend that to represent carbon 5. And so I have a triple bond between carbon 1 and 2. So I just need to add 2 more bonds. Okay. And I have a methyl and a fluorine on carbon 3. So here's my methyl, and here's my fluorine. And on carbon 4, same thing. I have a methyl group, and I have a fluorine. You can switch the positions however way you want. You just got to make sure that I see a methyl group and a fluorine on the correct carbon number. Okay. And so if I want to clean up my work, I'm just going to go ahead and erase some stuff, okay, just so that you guys can see what this looks like. Oh no. You guys get it. Okay. All right, so this is going to be my organic compound. This is my skeletal structure for this specific organic compound. All right, so hopefully by going through all of those examples, you guys get a better understanding of how to draw alkenes, draw alkynes, and name alkynes. So the next lecture video we will talk about is isomers. And so we're going to skip cycloalkenes and cycloalkynes for this semester. All right, see you in the next lecture video.